Welcome students to the second session of chemical reactions and equations. In the previous session, we have learned about chemical reactions. In this session, we will learn about combination reactions, decomposition reactions, displacement reactions, and double displacement reactions. Combination reaction. A reaction in which a single product is formed from two or more reactants is known as combination reaction. Examples of combination reactions. Burning of coal. In this reaction, carbon combines with oxygen to form carbon dioxide, which is a single product. Another example for combination reaction is the formation of water from hydrogen and oxygen. Decomposition reaction. A reaction in which a single substance decomposes to give two or more products is called decomposition reaction. Decomposition reactions are opposite to combination reactions. Different types of decomposition reactions. A decomposition reaction takes place only when some amount of energy in the form of heat, light or electricity is supplied to the reactant. Decomposition reaction can be classified into three types. Thermal decomposition reaction. The decomposition reaction caused by heat is called thermal decomposition reaction. Example, decomposition of calcium carbonate to calcium oxide and carbon dioxide. Another example of thermal decomposition reaction is heating of ferrous sulfate crystals. Ferrous sulfate crystal, which is green in color, lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide, sulfur dioxide and sulfur trioxide.
A decomposition reaction is one in which a single reactant breaks down to simpler products. Here is one such example. We have some ferrous sulfate crystals. Take the ferrous sulfate crystals in the test tube. Heat it over the flame. Initially, the crystals decolorize as they lose the water of crystallization and turn anhydrous. The anhydrous ferrous sulfate then further breaks down into ferric oxide and a mixture of sulfur dioxide and sulfur trioxide. In fact, you will be able to detect the distinct smell of burning sulfur, but do not stay around for long since sulfur dioxide and sulfur trioxide are toxic gases. The decomposition reaction can be represented as 2FeSO4 gives Fe2O3 plus SO2 plus SO3.
Photo decomposition reaction. The decomposition carried out by light is called photo decomposition reaction or photolysis. Example, breaking of silver chloride into silver and chlorine in the presence of sunlight. Silver bromide also decomposes in the same way. These two reactions are used in black and white photography. The decomposition carried out by electricity is known as electro decomposition or electrolysis. Example, electrolysis of water. Another example for electrolytic decomposition is decomposition of sodium chloride. On passing electricity through molten sodium chloride, it decomposes to sodium and chlorine. Displacement reaction. Here, the reaction in which a more reactive element displaces the less reactive element from its compound is called displacement reaction. Example, reaction of iron nails with copper sulfate solution. Now we can watch a video showing the reaction of iron nails with copper sulfate solution.
Reaction of iron nails with copper sulfate solution. In this module, you will learn about the reaction of iron nails with copper sulfate solution. When an iron object is kept in copper sulfate solution, the color of the object and the copper sulfate solution changes. Let us perform an activity to find out the details of this color change. For this activity, you will require iron nails, sandpaper, test tubes, copper sulfate solution, thread, clamp stand, and test tube stand. Take 2 test tubes marked as A and B, and in each test tube pour about 10 milliliter of copper sulfate solutions. You will find that the original deep blue color of the copper sulfate solution has faded away. What is the reason behind these changes? When iron nails are dipped in copper sulfate solution, the iron metal reacts with copper sulfate, which results in the formation of ferrous sulfate and copper metal. In this reaction, iron being more reactive than copper displaces copper from the copper sulfate solution and forms ferrous sulfate, which fades the deep blue color of the solution. The displaced copper then deposits on the iron nails in the form of a reddish-brown coating. Since in this reaction a more reactive metal iron displaces a less reactive metal copper from its compound, it's a displacement reaction. In this module, reaction of iron nails with copper sulfate solution. In this module, you will learn about the reaction of iron nails with copper sulfate solution. When an iron object is kept in copper sulfate solution, the color of the object and the copper sulfate solution changes. Let us perform an activity to find out the details of this color change. For this activity, you will require iron nails, sandpaper, test tubes, copper sulfate solution, thread, clamp stand, and test tube stand. Take 2 test tubes marked as A and B, and in each test tube pour about 10 milliliter of copper sulfate solution. Fix test tube A on the clamp stand and keep the test tube B as control sample in test tube stand. Now, take 3 iron nails and clean them by rubbing with sandpaper. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube A for about 20 minutes and keep the third nail aside. After 20 minutes, take out the nails and keep them beside the unused clean nail. Do you observe any change? On comparing both the nails with the unused nail, you will find that the iron nails, which are kept in the copper sulfate solution, have developed a reddish-brown layer on them. Now, take out the test tube A from the clamp stand and keep it beside test tube B for comparison. On comparing both the solutions, you will find that the original deep blue color of the copper sulfate solution has faded away. What is the reason behind these changes? When iron nails are dipped in copper sulfate solution, the iron metal reacts with copper sulfate, which results in the formation of ferrous sulfate and copper metal. In this reaction, iron being more reactive than copper displaces copper from the copper sulfate solution and forms ferrous sulfate, which fades the deep blue color of the solution. The displaced copper then deposits on the iron nails in the form of a reddish-brown coating. Since in this reaction, a more reactive metal iron displaces a less reactive metal copper from its compound, it's a displacement reaction. In this module, you have learnt that iron metal displaces copper from its compound copper sulfate and forms iron sulfate along with copper metal. This reaction is a displacement reaction.
Double displacement reaction. The reaction in which two different atoms or groups of atoms react by an exchange of ions to form two new compounds is called double displacement reaction. Example: potassium iodide react with lead nitrate and produces lead iodide and potassium nitrate. Now we can watch a video showing double displacement reaction.
In this experiment, we will study the reaction between lead nitrate and potassium iodide. For this, we will need lead nitrate salt, potassium iodide salt, 2 test tubes, a test tube holder, spatula, water, and a dropper. Take about half a spatula full of lead nitrate salt in a test tube and fill it up to 1/4 full with water. Now shake the test tube till the salt is dissolved to prepare an aqueous solution of lead nitrate. Similarly, prepare an aqueous solution of potassium iodide in a separate test tube. Add the aqueous solution of potassium iodide to the aqueous solution of lead nitrate. You will observe a yellow colored precipitate is immediately formed in the test tube. This is lead iodide. A chemical reaction in which there is a mutual exchange of ions between the reacting compounds is called a double displacement reaction. In this reaction, lead nitrate and potassium iodide react with each other to form lead iodide and potassium nitrate. As there is a precipitate of lead iodide formed in this reaction, this is also an example of precipitation reaction.
Points to remember. In a combination reaction, two or more substances combine to form a new single substance. In a decomposition reaction, a single substance decomposes to give two or more substances. When an element displaces another element from its compound, a displacement reaction occurs. Two different atoms or group of atoms are exchanged in double displacement reactions. At the end of every class, you will get an assignment. Write this assignment in your science notebook. Today's assignment is NCERT textbook page number 15, question number 5, 6, 7 and 8. Thank you. Take care.